Hi everybody. As the last step to the series, we have multiple players, but the players can't interact at all, and they also aren't notified of events that happen in the game world, particularly when other creatures wander into and out of the rooms that the players are members of. So we're going to use a variation on a really important design pattern called the observer pattern. And this is sort of complicated enough that I wanted to explain it a little bit first before we jump into the coding. So let me talk about the observer pattern in general, and then we'll talk about the variation of it that we're going to use, using slightly different language that I think will make more sense in our context. So in general, the observer pattern is a way of implementing an event-driven framework. So the idea is we have lots of different objects in a complicated system, and some of these objects trigger events, and other objects want to be notified when these events happen. So the way the framework works is typically as two interfaces. There are observable objects that implement the observable interface, and those are the ones that are going to be triggering the events. Then there are observer objects that are interested in knowing when certain things are going to happen, and they're the ones that get notified. They implement the observer interface. The observable interface really just has two important methods: add and remove observer. So the way you should think about it is, if the object is going to be triggering events, it needs to keep a register of who are all of the other objects that need to be notified when something happens. Usually this is just like an array list inside the object. But we want to keep the implementation open, so that's why it's usually defined as an interface. So if you have a class that wants to be observable, they might, for example, have a list of observer objects inside the class. And then when a different object wants to register itself, it will ask that observable object, hey, could you please add me to your list, by running the addObserver method. Then when something interesting happens, the observable object will loop over all of the observers that have registered themselves and run the observers on event method. And then the observing object can decide what it wants to do when the event happens. But at least now there's a way for the observed object to trigger or to notify the observing objects that something's happened. Very often there's going to be a third object or interface and set of implementing classes to handle the different kinds of events. So like when an observed object wants to trigger that something's happened, it will construct an event object, usually a subclass of an event, of an abstract event object, that captures the kind of thing that happened, and then when it loops over all of its observers, it will hand them the object, the event object that encapsulates all of the important information about the event that happened. Okay, cool. So that's the general kind of pattern, and this is actually probably a good pattern for us to implement later. I'm probably not going to do it in these videos, but I mean, this is like an interesting enough framework that we might want to have an event-driven framework as a part of it. For us, we want to use this pattern for communication channels. Remember, because we want, for example, a player to be able to say something and all the other players that are part of the same room to hear what was said. So rather than an observable object and an observer, instead we're going to have a comm channel object and a listener. But the overall relationship is very similar. So a comm channel can have a whole bunch of subscribers that are listeners. Oops, forgot to change the data type here. So let's do an example. Let's say that a room will implement the comm channel interface. So every room is its own communication channel. What can happen is any player that enters the room, and then the players will implement a listener interface. So when a player enters a room, they'll add themselves as a listener to that room's communication channel. And then when anything interesting happens in the room will loop over all of the listeners, which is all of the players in the room, and it will run each player's onMessage event method. And that will be a way of notifying each player that something interesting has happened. And then the player can go ahead and decide what they're going to do. And typically, I think that that will be just displaying the message to the client handler that's connected to that player. And then when a player leaves the room, they'd remove themselves as a listener from that room. So that's like a very flexible idea. On the flip side, you could also think about players as having comm channels. So if you wanted to like set up a private chat with somebody, you could register yourself as a listener. You could register each other as listeners on each other's comm channels, and now you have a way of communicating with each other. That would also let you set up kind of arbitrary group chats, because all you would need is a new object that implements comm channel, and then a whole bunch of different players could add themselves to it. And then whenever one player ran the print line statement, the comm channel would loop over all of the other listeners and kind of broadcast that same message to them. So that's the kind of idea, and I hope you recognize that kind of abstractly it's the same overall relationship. One important difference that I wanted to highlight was here we've got this print line statement, and here there's nothing. My thinking there is the observed object, or the observable object, is the one that would be triggering events in this framework. But it's really the object itself that would undergo the event and decide when to do the triggering. Like a different object couldn't say when a certain event was going to get triggered. Here, the relationship's a little bit different. Like comm channel really is more like an object that other things can use. You can think about it as like a broadcaster. So anybody who has a reference to a comm channel object could run the print line method here. And what that would do is it would loop over all of the listeners and notify all of the listeners by running their on-message event methods. So instead of the comm channel being the triggering object, comm channel is sort of like a conduit that would let other things notify all of the listeners of the comm channel. Okay, so let's dive in. So let's make a new interface called comm channel, and yeah, let's do that. So add listener and remove listener. And I had print line, but maybe we should have broadcast. I think that's maybe more descriptive. Great. So now let's create interface listener inside TextWorld. Okay, and anyone who is a listener will have, what did I call it? I called it on message event, I think. All right, great. So one interesting aspect of making a comm channel be an interface is it means that we could actually have a class that implements the interface that is a comm channel. And then you could have that comm channel be a field in another object. So for example, a room could have a comm channel as a field inside of it. An alternative is the room class itself could implement the comm channel interface, in which case a room is a comm channel or can be treated as a comm channel. I'm not sure if the difference between those, if you feel a lot the difference between those right now, but maybe we'll, I don't know, I haven't really thought this fully out yet, so maybe we'll have occasion to implement kind of both approaches. For the moment, let's go ahead and go, where's level? Let's go ahead and go to room, which was the inner class of level. Public class room. Okay, so let's have room implements comm channel. Great. So now let's go back to where we were. So what that means is that the room needs, I'm going to give it an array list of listener objects, which I will call listeners. And now we're back down here at add listeners, so I'll say this.listeners .add L, and this.listeners remove L. And then for broadcast, let's loop over all the listeners, and we'll run the listener method on message event. And so in other words, we're just, whatever we were told to broadcast, we will now loop over all the listeners and broadcast that to them by handing that message to their on message event. Cool, so that is now done, except I don't think I actually initialized the array list. So let's do that. Okay, so on the flip side, let's have our player objects be listeners. So we're extending creature. Do we want a player to be? Yeah. Implements listener. So now we'll implement the unimplemented method on message event. And I think we'll just run our own print line using that message. So in other words, when we get notified of a message, we'll just turn right around and send that message off to the client handler using the print writer that was given to us by that client handler. Okay, so let's start by broadcasting the movements of creatures, I think. So if you remember our implementation, rooms themselves don't keep track of who's in them, I believe. Yeah, that's right. So rooms don't actually have a list of creatures. Only the creatures themselves know what rooms they occupy. So what that means is if we want to broadcast whenever a creature moves from one room to another, it's got to be the creatures themselves that trigger that broadcast. So so autonomous creature is my abstract class that all creatures extend. So the move method here, let's see. So the move method here chooses the next room, and then if the room isn't null, then we run move to neighboring rooms. Let's go there. And then that runs this one. Okay, so move to neighboring room is kind of the only way that creatures move from one room to another. So we check if the room has the appropriate neighbor, and if it does, we update the current room. So I think this is where we want to do all of the broadcasting. If we wanted to, at this point, well, here, let's put it in, and then we can talk about other kind of options. So right before we change the room, let's do this. Let's say, so room next equals current room dot get neighbor name. Right, it's level dot room, I think. Great, and so now we'll say next dot broadcast this dot get name. So whatever creature is leaving has left the room, and then we'll say current room dot broadcast this dot get name has entered the room. Great. And I think that's it. So that seems like a very small set of changes we've made, but I think that should be sufficient. So let's go ahead and give it a try. Maybe this will be the first thing that works the first time. All right, so server, we will run. Great. I gotta figure out where I'm printing this and remove it. Close all, oops. Okay, so then client. So I think if we sit here, in theory, because chickens and pop stars and other things are all creatures, they should be triggering these same broadcasts. Oh, wait, I'm sorry, we haven't subscribed ourselves to anything yet. So the broadcasting is, so far as we believe, happening, but we forgot to have the player register themselves. So that probably shouldn't happen in player, or at least it shouldn't start out in player. It should probably start out in the command. So yeah, in the go command here, so let's see, in the execute, okay, so before, alright, so I guess player maybe needs to have its own version of move to neighboring room. Because we don't want, other creatures aren't listeners, so we don't want other creatures, I can't put the listener code in here. I mean, we could have other creatures be listeners and just ignore the broadcasts. But let's not do that. Let's go back to player and let's override this guy. So here I am in player. I'm overriding the method where what I'm going to do is I still want to do the same stuff, so I'll run the parent version of the method. Does that return Boolean? It does, great. So it returns Boolean if it was successful. So we'll say I need to know. Okay, so before we run, we need to remember like what our current room was. So room old room equals this dot current room. Get current room. Okay. Okay, so you'll see what I have in mind. So I'll save a reference to whatever the current room is. Then I'll try and move using the parent. If it was successful, so if it was successful, then I'm going to unregister myself from the old room and re-register myself to the new room. So old room dot, what was it called? Add listener. This, because remember, we're inside player and player is a listener. So we're saying, please let's add ourselves, oops, not add. Please let's remove ourselves from the old room that we just left so that we're not listening to what's happening in there anymore. And this dot get room dot add listener this. So we'll add ourselves as a listener to the new room. If it was unsuccessful, nothing has changed, so we don't need to re-register or unregister ourselves. And then let's return success. Great, so I think that's going to work. The only thing that's missing now is the only thing that's missing is where we set our current room. That happens up in the constructor, so let's also say in the constructor get room.addListener this. Okay, so now I think we're ready for a legitimate test. Server, go. Client, go. So here we are. I'm going to sit here for a second and see if chicken's coming in and out. I guess another thing that we can do, there we go, chicken has left the room, chicken has entered the room. Let's make another player and we'll see if the players can sort of sense each other at all. So run a second client. Well, let's look at the first client. Or here, let's do this. So look, so let's go bedroom. You have moved to the bedroom, and meanwhile the first client, okay, interesting. So nothing's displayed in the first client. So only chickens, but not players. So I wonder what's gone wrong here. Okay, I think I found at least one bug. So I'm broadcasting that I left the room, but I'm broadcasting that to the room that I am going to, the next room. So really what I want to do is say current room, so-and-so has left the room. And then, so really I don't need this at all, because I'm telling the current room, hey, I'm leaving. Then I change the current room, and then I tell my new current room, hey, I'm here. All right, so that makes some sense. Let's try it one more time. I think that might have been the only problem. And let's do one more client. So now I've got 2 clients. This client is going to go to the bedroom. And so it displays that I myself have left the room before it says you've moved to the bedroom. We might want to have the messages about ourselves not display, but over here it says that the other guy has left the room, and meanwhile chickens are coming and going. So let's do this. Let's have this one. Great. So go bedroom. Lilith the Brash. I should fix all of these visual bugs. And meanwhile, here it says Lilith the Brash has entered the room. Okay, so that seems to be working. So as an exercise, I think that you should make a new command called the say command. And the way that it works is you type say and then a message. And whatever message you type then gets broadcast to all the listeners in a particular room. So in other words, you are saying something out loud in the room, and anybody else who is in the room will hear what you say. And then give that a try. All right, I think maybe that will be enough for the moment. But if there's enough interest, maybe we could try and do some other things in here. I hope this has been an educational experience for everybody. Thank you.